Yeah, hello everyone. Myself Maruti, welcoming you all to this math session. So, in this video, I'm going to explain you regarding rational numbers, whether those rational numbers are terminating decimals or non-terminating decimals. I like to repeat, terminating or non-terminating, that is the first model. If they are terminating, after how many decimal places they are terminating. And the third model, converting into decimal form, means converting in terms of decimals. The fraction, the rational number which is written in the p by q form, we will convert in terms of its decimal. So the first model, we are given a rational number in the p by q form and we are checking whether it is terminating or not. So the rule we have already written here, if the denominator is in the form of 2 to the power m into the 5 to the power n, it is terminating. If the denominator is not in terms of this model, then we say it is a fraction, it is a rational, but it is not terminating. It may be it is non-terminating. Let us check it out with the help of an example. 13 by 3125 is the rational number given. Why? Because it is in the p by q form. Let's check how can we write the denominator of that one. So prime factorization of denominator. So what's the denominator here? We are having 3125. Okay, so let's do the prime factorization of that one. As the last digit is 5, we can say it is divisible by 5. Let me divide by 5. So it's nothing but 6 to 5, right? Again go with the 5. It's nothing but 1 to 5. Again go with 5. It's nothing but 25. Again go with 5 and it's nothing but 5. So 325, 3125, if you prime factorize that, how much we are getting? 1, 2, 3, 4, 5. So 5 to the power 5 we are getting. Right? Now the denominator, how it is looking like? The denominator is looking like 5 to the power 5. Is it in the form of 2 to the power m into 5 to the power n? We are able to see only 5 there. Is it in the form of 2 to the power m into 5 to the power n? Start thinking. Let's do one thing. So can I write this as 5 to the power 5 into 1? Does it make any matter? No. Now, can I write it as 5 to the power 5 into 2 to the power 0? Yes, man. Anything to the power 0 is nothing but 1. Now, are you able to see the denominator 3125? Right. If you check it out, it is in the form of 5 to the power n into 2 to the power n, right? So, as the denominator is in the form of 2 to the power m into 5 to the power n, the fraction 13 by 3125 is a terminating rational number, as denominator is in the form, what's the form it is looking like? 2 to the power m into the 5 to the power n, it's terminating. It's a terminating. If it is not in the form of this, we say it is not terminating. Let's go with one more example what is given there. Now see the denominator. Yes, it is already prime factorized. It is factorized in terms of its prime numbers. But if you see the denominator, it is not only in the form, it is not only having 2 and 5 as factors, we are having 7 also as a factor. So as the denominator is not in the form of, right, as here, as denominator is not in the form, right, in the form of, right, 2 to the power m into 5 to the power n, this one we can say is non-terminating. It's non-terminating. You have to remember this one. If the denominator is in terms of 2 to the power m into 5 to the power, means only simple. We can have 2's in the denominator, only 2's. Or we can have only 5's in the denominator. Right? Or we can have both 2's and 5's. Except these two, we should not have any other number like 3's or 7's or 11's in the denominator. Then if we are having only 2's or only 5's or both the combination of 2 and 5, it's fine. It is terminating. Otherwise, it is non-terminating. You have to remember. That's the model of rule 1. Now let's go for the rule 2. Alright? If the denominator is terminating, means the denominator, if the fraction is terminating, if the rational is terminating, fine. After how many places it will terminate? Let's go with the prime factorization of the denominator. 400, I'm going with the 2, it's nothing but 200. Again I'm going with the 2, it's nothing but 100. Again I'm going with the 2, it's nothing but 50. Again I'm going to go with the right 25 and 5 and 5. So the 400, which is nothing but the denominator, 1, 2, 3, 4, 2 to the power 4 into the 5 to the power 2. Yes, the denominator here, which equals 229 by how much we are writing? 2 to the power 4 into 5 to the power 2. Yes, it's terminating. Yes, it's terminating. Right. The rational number. Right. What's the rational number? 229 by 400 is terminating fraction or terminating fraction. I accept. But after how many decimals? This is the rule what we are given. See the powers of both of them. Right? Whichever is the highest, then you say it is going to terminate after those many decimals. Now see here, out of here, 2 to the power 4 and 5 to the power n. Shall I say 4 is the highest number? Yes, 4 is the highest. Therefore, the fraction, it terminates after 4 decimal places or 4 decimals. You have to remember. Simple logic. After the denominator in the form of 2 to the power m into 5 to the power n, see the highest number, tell that those many times, after those many places, the fraction will terminate. That's the rule 2. Now let's go for the other one. Yes, here we are checking whether it is terminating or not by seeing the fraction in the form of 2 to the power m and 5 to the power n. Here, after seeing the denominator as terminating, after how many places it terminates means seeing the highest number, we say it terminates after those many places. The third one, after seeing it is terminating, after knowing after how many places it is terminating, we have to convert in the form of the decimal places. Now see here, 15 to the power, it's nothing but 2 to the power 4. 2 2s are 4, 4 2s are 8, 8 2s are 16. Is it terminating? Yes, denominator is in the form of, right, 2 to the power m into 5 to the power n. Of course, if it doesn't have 5, it is nothing but 5 to the power 0. You have to remember. And out of these two, which is the highest, it gets terminated. It gets terminated after, which is the highest of 4 and 0? 4. 4 decimal places. Right, it terminates after 4 decimal places. Yes, it's fine, but he's asking us to terminate that and show it to me. We will do one thing. 15 by 2 to the power 4 is there. Okay, now to pair up with this, right, how many 2's are there? Can I write it as 2 into 2 into 2 into 2? Yes, right. To make it equal with 5's, how many 5's we need? Here, how many 2's we have? 4 2's we have. Now bring 4 5's there. Right. So that is nothing but 5 to the power 4. That 5 to the power 4 multiply and divide by the both numerator and denominator. That's the simple logic. 2 to the power 4 is there. Right? How many 5's are missing to pair up with that? 4 5's. 4 2's, 4 5's. That is what we are going to do. 5 to the power 4 by 5 to the power 4. This is the logic what we are going to think on. So to pair up with the 2 to the power 4, how many pairs of 5's are there? How many 5's should be there? To pair it up like this, I like to see like this. 5 into 5 into 5 into 5, 5 into 4. Right? See here, the first two paired up with this paired up, right? Now 2 5's are 10, 2 5's are 10, 4 10's we are having all zeros. That's the logic. So we have to think on. So it is nothing but 15 into 5 to the power 4 by 2 to the power 4 into 5 to the power 4. Okay, now I'm combining this one. 15 into, right, 25 into 625 by 2 into 5 whole to the power 4. I'm converting like this. Now again what I'm doing, right, 15 into 625 by, can I write it as 10 to the power 4? Yes, it's nothing but 10 to the power 4. It becomes, right, by, it's nothing but 4 zeros and 625 into 15. 5 5s, 25, 5 2s, 10, 12, 5 6 30, 31, 625, it's a 5739. It's nothing but 9375. But here, how many 4 places? 4. Bring it back for 4 places. It's nothing but 0.9375. So here 15 by 16 is nothing but it's terminating. After 4 places it is terminating, and I have converted in the form of decimal form. What is the simple logic? 2 to the power 4. Okay, how many 2's are there? 4 2's are there. To pair those 2's with the 5's, how many 5's are needed? 5. Why? Because 2 5's first to 10, there are totally 4 10's. 2 5's, 1 10, 2 5's, 2 5's, 2 5, totally 4 5. Means we have to check it out how many are required and we have to work on. So this is the method to find whether it is terminating, to find after how many decimals it is terminating, and to know the decimal form. Come back for the next example here. So 23 by 80 we are supposed to convert in the form of decimal. So here what we are doing, we are taking the denominator. What's the denominator here? The denominator is nothing but 80. Let's prime factorize that. Prime factorizing. Prime factorization. Right. Prime factorization of the denominator. What's the denominator here? 80. Now let us do prime factorization. It's nothing but 40. Again 2, it's going with the 20. Again 2, it's going with the 10. And again 2, it's going with the 5. Okay, now 80, how we are writing it that? 1, 2, 3, 4. 2 to the power 4 into 5. Of course, 5 to the power 1. Okay, let's come back to this one. 23, the 80 we are writing in the form of 2 to the power 4 into 5 to the power 1. Okay, now if you see the denominator, how many 4's it has? It is nothing but, right, 2 into 2 into 2 into 2. 4 4's it has, and 5 is only 1. Okay, if you check it out, so 2 into 5, it's nothing but 110. Okay, but what about these 3 2's? How can we pair that one? If we have one more 5 here, right, I can pair these 2, I can make it as one more 10. And if I have one more 5 here, these 2 are the extra what we brought. Right, I can pair these 2 and I can make it as one more 10. And if I have one more 5, I can pair these 2, I can make it as one more 10. So how many 3's we bought it as extra there, so that everything becomes in terms of 10. I brought 3 5's. So here it is nothing but 5 to the power 3. Okay, so we need 5 more 3's, right? 3 more 5's to make everything in terms of 10's. Therefore, here whatever we are having, 23 by 2 to the power 4 into 5 to the power 1, to bring those extra 5 to the power 3, what I am doing, I am multiplying a denominator with that 5 to the power 3, that is into 5 to the power 3 by 5 to the power 3. Now you got why I took 3 more 5's. Why? Because the total combination should be all 10's. Why? Because 2 into 5 equals 10. Okay, if we have all in terms of tens, we can convert into decimal very easily. Now it is, now if you check it out, the numerator 223 into 125, which is nothing but 5 cube. Now let's pair it up. 2 to the power 4 into 5 to the power 3 plus 1, totally 5 fours. Okay, now I can write it as, if you multiply this one, so 125 into 23, 3 5s 15, 3 2 6 7, right, 3 5s 57, 3 1s 3, it's nothing but 250 here, 5 7 8 2, 2875, accepted. 2875 by, if you pair it up, 2 into 5, 2 5 10. But how many 4s? 1, 2, 3, 4. 4 4s, that is 2875 by 10 to the power 4. Okay, you got it. Now I can convert that one as 2875 by how many 4s? 1, 2, 3, 4 zeros. Okay, now as you know the decimal is here. How many times it has to go back? 4 places. It is nothing but 0.2875 means first place, second place, third place, and the decimal went there. 4 places. So that is how. So 23 by 80 can be written in the form of 0.2875. Hope you understand. In this channel, I have been placing both math and science videos.